Welcome to This Explainer. Today, we're diving straight into the bizarre, honestly kind of fascinating intersection of human biology and computer science. Look, you probably view the computer on your desk or the phone in your pocket purely as a machine, right? Just wires, silicon, and static lines of code. But today, we're going to completely shatter that perspective. We're looking at some incredible research that literally redraws the boundaries between the biological world and the digital landscape. Let's get into it.
So what does a computer hack actually have in common with syphilis? I know, it sounds totally absurd. On one hand, you've got a malicious string of code typed out by a hacker in a basement somewhere. And on the other, you have this devastating biological infection that's plagued humanity for centuries. But as we unpack the source material for you today, you're going to see that the behavioral parallels between these two forces aren't just coincidental. They are actually functionally identical.
Take a rootkit versus neurosyphilis, for example. In human biology, neurosyphilis doesn't just hang out on the surface, it burrows deep into the nervous system. That is the absolute command center of the human body. Well, a rootkit does the exact same thing digitally. It completely bypasses your surface-level apps and embeds itself directly into the OS kernel, which is effectively your computer's digital nervous system. Once it's locked in, trying to extract it without destroying the host itself is incredibly difficult.
Life cycles of digital pathogens. The comparison doesn't stop at where these threats hide. It extends directly to their fundamental reason for existing.
Think about it. Both biological and digital viruses share an identical two-step life cycle. Step 1, find a host program. Step 2, replicate code. They absolutely require a host to do this. A biological virus out in nature just sits there, completely inert, until it invades a vulnerable living cell and hijacks its machinery to churn out copies of its DNA. Digital viruses follow this exact same script. Malicious code can't just run out of thin air. It actively hunts down a vulnerable host program on your computer, attaches itself, and then completely hijacks that program's processing power to replicate its own digital DNA.
And just as biology gives us different classes of pathogens, the digital world has its own taxonomy of digital pathogens. First up, we have worms. These are aggressive, self-replicating outbreaks that spread from machine to machine without you even having to click anything. Next are Trojans. These deceive you by disguising themselves as totally legitimate software just to bypass your defenses. And finally, fileless malware. This stuff operates entirely in a computer's active memory, leaving almost zero footprint on the hard drive. It functions exactly like a highly stealthy, asymptomatic infection. The structural pattern here is just undeniable.
Now, let's talk about ransomware and Al Capone. To truly grasp the horrifying reality of digital memory locks, the source material points us to one of the most notorious figures in history and what actually happened inside his brain.
12. That number represents the tragic mental age that the infamous Al Capone was reduced to due to his physical decline from neurosyphilis. You know, Capone was a formidable, sharp, and completely ruthless crime boss, but the biological pathogen inside his nervous system systematically attacked his brain. It aggressively degraded his cognitive functions, effectively locking away his adult memories and faculties. His mind, which was once this highly complex and powerful machine, was severely restricted to the raw capacity of a 12-year-old child.
So how does this connect? Well, Capone's cognitive decline actually mimics ransomware locking a system's memory. It serves as a visceral mirror to what ransomware does. Think about it. Ransomware invades a highly complex, functioning system, like your computer network, and it encrypts the data, entirely scrambling the memory. Just as neurosyphilis locked away Capone's cognitive abilities, ransomware literally locks away the machine's mind. The computer's still physically sitting there, the hardware is powered on, humming away, but the system is fundamentally incapacitated because its memory is completely inaccessible to you. The biological decline and the digital lockdown, they mirror each other perfectly.
The digital organism. Throughout this explainer, we've seen rootkits mimicking nervous system infections, identical life cycles relying on hosts, and Capone's cognitive lock perfectly mirroring modern ransomware. All of this evidence leads directly to a massive paradigm shift.
We really need to stop viewing code merely as a tool. Instead, we have to look at code as a digital organism that replicates and hijacks hosts exactly like biological DNA. Honestly, if there's one main takeaway for you today, it's this. We're so conditioned to think of code as a static tool, right? Like a hammer or a wrench built by a human. But when malicious code exhibits this innate drive to find a host, hijack critical resources, and replicate its own instructions, it crosses a threshold. It functions as a living entity, driven by the exact same survival imperatives as biological DNA.
So as we wrap up, I want to leave you with a provocative thought about the trajectory of these threats. If we accept this profound reframe, that digital pathogens are essentially living organisms functioning like DNA, we have to confront the rules of biology.
And what's the most fundamental rule of biology? Evolution. Biological pathogens continuously mutate and adapt to survive our immune responses and treatments. So, if malicious code is truly a digital organism, it's not going to just sit still. It's going to mutate and evolve to bypass our digital immune systems. Which leaves us with a slightly terrifying question to ponder. If code replicates like DNA, what will these digital organisms evolve into next? Keep questioning what you think you know.